Fish enter a lake at a rate modeled by, so they already tell you it's a rate, so you already know this is a derivative. It's an amount going in at a certain time period. Okay, fish enter a lake at a rate modeled by the function E, given by E of t equals some stuff. Fish leave the lake at a rate modeled by the function L, given by L of t equals some stuff. Obviously, we've seen some trig and some exponentials in there, right? Both E of t and L of t are measured in fish per hour, and that gives away that it's a rate again, okay? And t is measured in hours since midnight. Now, if you integrate the rate, you get the amount. That's something they can ask us. They can ask us about how many fish are in the lake at a given time period. Did they tell us how many fish were in the lake at the initial quantity or initial time? No. It's just there's some in there or there's not any in there. Some are entering, some are leaving, and let's see what happens. Now, because this is a rate in, rate out, two things are happening at once. You need to combine those two for our integral usually, okay? Now, part A. How many fish entered the lake over the 5-hour period from midnight t equals 0 to 5 a.m., which is t equals 5? Give your answer to the nearest whole number. I hate rounding animals and people because, I don't know, half humans, whatever. Now, they're only asking about entering the lake, right? So we're only going to integrate E of t. So for number 1, part A, we got antiderivative. Boundaries are 0 and 5. E of t dt. This is definitely a calculator problem. You write your setup and then go calculate it. Integrate the rate to find the amount. And what do we got? $153 point what?
457.
Okay, so when I write my answer, I'm going to do that, but then my concluding statement, I'm going to round it. Okay. All right. The amount, or we can say this. Let's do this. Approximately 153 fish enter the lake. Wow. Enter the lake from midnight to 5 a.m. Boom. Now you get 1 point for your integral setup. And you get 1 point for your answer. Okay? So that's really giving that is where they are awarding you points, and that's why I'm always telling you guys, write down what you're going to do and then do it. Okay? Don't assume they know what you're doing. Be very precise and specific. Okay, what is the average number of fish that leave the lake per hour? Now this is where people just really didn't know what they were asking, because it says what's the average number of fish that leave the lake per hour? Well, that's a rate, isn't it? Because it says fish per hour. They want the average rate, and they give you the rate equation. That's an average value formula problem, right? Remember we said if you want the average height given the height, that's average value. If you want average amount given the amount, that's average value. If you want the average rate given the rate, that's an average value. 1 over b minus a, antiderivative a to b, f of x dx, right? So since they want the average of the rate and they give you a rate problem that is an average value Formula 1. So they want the average number of fish that leave the lake over the 5-hour period from midnight to 5 a.m. So that would be 0 to 5, 1 over 5 minus 0. And then this would be L of t dt, correct? And L of t will be in your y2. And what's the answer?
$6.059.
Okay. Justification, confirmation on the answer. And more of you guys got the same thing? Okay. The average number of fish that leave the lake per hour from midnight to 5 a.m. is 6.059. And what's the units on 6.059? Fish per hour. So the reason why is, so 1 is just the number 1 divided by, what's 5 minus 0? What's the units on 5 minus 0? That's time, right? That'd be your hours. 1 over hour. If we integrate to this rate, what do we get? The amount, and what are we talking about? Fish. 1 over hour times fish is fish per hour. Okay? Okay, 1 point for integral, 1 point for answer. C. And again, guys, if you get these first 2 parts all the way correct, you are already above average. Just like your parents tell you, you're above average. At what time t for 0 to 8 is the greatest number of fish in the lake? What type of problem is this? Optimization problem, but what else? What else? I mean, when they
Max events, right?
which is candidates test.
That one, yeah.
Yep. Okay. So there are other ways to find the answer in this one, but what has been helpful over the years is just always handle these ones the same. This is a candidates test. Okay. Now you'd handle the optimization problems in the candidates test almost the exact same way, right? Except for in these candidates test ones, you have to consider the endpoints and the critical numbers, right? So, and because it has a closed interval too, 0 to 8, they gave us rates. Those are derivatives. Okay. Now to find the critical numbers, you have to consider entering and leaving at the same time. That means you have to consider E of t minus L of t equal to 0. And fun fact, guys, you already have E of t in your y1, L of t in your y2. Wouldn't that just mean E of t has to equal L of t if we add L of t over the other side? And now we don't have to graph a new function, just see where the two graphs cross. That'll give you your critical numbers. We set up our candidates table of t and EFT minus FFT at the derivative. 0 and 8. I know for sure. I don't know how many others there are. When you find them, give them to me, please. About 6 point something. 6.203. Now that's rounded. You better be storing that answer in your calculator right now as A, because we're probably going to have to use that in our calculations. Okay, now we got to find when the greatest number of fish are in the lake. They only want the time, they don't want the amount, but we have to find the amount so we can find the time, right? Is that 0, 6, or 8? Now, how do you find the amount of fish? Well, that's an integral. Integrate the rate to find the amount, and that would be the integral for the first one, 0 to 0, E of t minus L of t dt, right? Now, that's pretty easy, isn't it? What's the answer? That's 0. Okay, now I could have just wrote 0 to t, E of t minus L of t, because then you could just use this and just type in your particular t values, 0, 6.203, which would be like your A stored value, and then 8 to get to our other two values. Real quick, will you figure out the number of fish in the lake at this time value and then at 8 also? And what are we getting for the first one?
155.014.
Or 0.15, I think, if we round it. And then what about at 8? Now what I like to do, I like to go up and highlight that integral I just typed in, hit enter, and then it just drops it down. You can arrow up, and then instead of having A, type in 8, hit enter again, and that's the least amount of buttons you have to push. And what do we get? About 80? 80.919 or 80.920, I believe that would be then, if we rounded. Okay? Now make sure you guys are practicing the calculator, typing all this stuff in as we go. You should be able to do it as quickly as I'm asking you to give me the answers. Okay? So by looking at the amounts of fish, obviously we can tell that the greatest amount is 135. That happens at t equals 6.203, right? Now, concluding statement, the greatest number of fish in the lake is at time t equals 6.203, period. So Mr. Bonnley, we did not, almost said Mr. Justification. Mr. Bonnley, we did not justify. Yes, we did. What's justification on a candidates test problem? The table, right? You found your candidates, you entered in that information into your integrals, and then we have a concluding statement, okay? Now, you are given 1 point for considering this. That means when is the rates, the sum of the rates, equal to 0, okay? And then we have our candidates, and then we have our answer. Questions on this? Always a candidates test problem, please. D. Is the rate of change in the number of fish in the lake increasing or decreasing? Now, aren't the equations they gave us rates? Yes. So if we want to know if what they gave us is increasing or decreasing, what do we have to look at? The what? Well, this is the rate. We want to know if the rate is increasing or decreasing. The derivative of the rate. We have to find the derivative of the rate and check to see if it is positive or negative, right? So they want to know, is it increasing and decreasing at 5 a.m.? That means we got to find out what is E prime of 5, and then what else? Minus L prime of 5, and that's a Math 8 problem. That'd be the derivative of y1 at x equals 5 minus the derivative of y2 at x equals 5. And let's see what that answer is. Any brave volunteers?
Negative 10.72.
0.722? Is that right? Now, and again, when we have to analyze the sign, or when the sign is important, we better obviously say if this is positive or negative, right? State the obvious. Negative 10.722 is less than 0, right?
Goodness. What a profound statement.
I know, right? It's just crazy. Therefore, in conclusion, the rate of change in the number of fish in the lake is decreasing at 5 a.m. because E prime of 5 minus L prime of 5 is less than 0. Done. Now, you are getting 1 point for considering E prime of 5 and L prime of 5, and 1 point for your answer with justification. Questions on this? I think getting a 7 out of 9 is pretty doable on these questions without seeing them ahead of time. And we've taken 19 minutes by slowly going over these and explaining them, right? If you'd have to listen to me talk you through these, you can get them done a lot quicker. So let's move on to the next one, which is 2018 number 1. This is on the A, B, and the BC question test. And this is one where after the test, everybody lost their mind. Mr. Bradley, they're getting on an escalator. They gave us a piecewise function. Who cares? A piecewise function is just 2 functions within a function, isn't it? That's not bad. It's just broken up by domains. Okay? People enter a line for an escalator at a rate modeled by the function r given by a piecewise function. Now, the top is used for time values 0 to 300. The bottom is used for values greater than 300. Let's say they wanted you to find something between 1 and 400. Well, guess what? You'd have to set up 2 integrals. One from 1 to 300, and then one from 300 to 400, because they'd be using different functions. Okay? Let's keep that in mind. So that's the rate getting in line for the escalator.
We're stuck on a problem.
Me too.
Don't get emotionally involved in the bananas.
Connor, why don't you off?
This class is better. Except for I'm still stuck with Matt, so it's really not.
R of t is measured in people per second and t is measured in seconds. As people get on the escalator, they exit the line at a rate constant 0.7 people per second. So there's your rate out. You guys want me to stop what I'm doing to help you? Come back at like at 11:20 or 2:25.
Okay. We're just not even.
I think they're special.
You can say that again.
There are 20 people in line at time t equals 0. Okay, now they gave us an initial quantity. I'm expecting us to ask exactly how many people are in line at a given time now, which means 20 would be important. Okay, now the rate out is a constant equation or a constant rate of 0.7. Not 0.7t, not 0.7x, 0.7. Part A, how many people enter the line for the escalator on the time interval 0 to 300? That means we're just using the top part of the piecewise function. This is a calculator active problem. Therefore, we're going to write our setup and then we're going to use your calculator. All right, entering only 0 to 300. R of t dt equals, and that's all you got to do. Is this a nice number?
Yeah.
What is it? 270?
That's not what I got. I have to go into my Y and see what I did wrong.
270. Well, that's a good thing you brought that up because that function is not very friendly, is it? It's kind of a little bit of a notation nightmare. Make sure you're using your parentheses correctly. You have 1 minus t over 300. Make sure you use your powers. You have 3 and a 7. 270 people enter the line. For the escalator. During the time interval. And then inclusive 0 to 300. And again, you could write it the way they wrote it. 0 less than equal to t less than equal to 300. Either way is fine. Okay? I like that we didn't have to round people. 2 points, guys. Already. Almost average. Part B. During the time interval 0 to 300, there were always people in line for the escalator. Okay. How many people are in line at t equal 300? Well, how many people are in line at t equal 300? That would be considering initial quantity, the antiderivative of the rate on, antiderivative of the rate off, right? Or out of line, I should say. So that would be 20 plus antiderivative 0 to 300. Rate in or rate on minus 0.7 dt. Mr. Balling, can I just take 20 plus 270 and then minus 0.7 times 300? That's what you're doing right here also, though. That's what you're doing. That would work, but this is what you're doing. And what do you get? 80. Yep. There are, or were, 80 people in line at time t equal 300. 2 points. For t greater than 300, what is the first time there are no people in line for the escalator? Okay, guys, how many people are in line at time 300? 80. Look at your piecewise function. R of t stands for people getting in line. What's the rate at which people are getting in line at after 300? 0. They shut the line down. You can't get in line anymore. Now it's just people getting off, right? What is the rate at which people leave the line? 0.7, right? So all you really need to do is figure out how long it takes for those 80 people to leave at 0.7 leave per second. And what do you get? 114.286. And that answer is correct for 80 divided by 0.7, but it does not fully answer the question. What should the answer be for the question? Is 114 greater than 300? So what do we have to do? Add 300 to it, right? Because they're asking after 300. 80 is how many there are in line at 300. And then it's 114 seconds more. So that'd be 414.286, right? So there are no people in line at time t equal 414.286. Now I should really say the first time there are no people in line. There are no people in line. And honestly, that should be the last time, right? Because the line was shut down. Part D, what type of thing have they not asked us yet? Max min problem, right? They're almost always going to ask something about max and min based on a rate in, rate out problem. What's the maximum amount of liquid in a tank? What's the maximum number of bananas on the table? What's the maximum number of people on the escalator? Or minimum number, okay? It's always going to ask that. So for 0 to 300, thank you, Lord, that's 0 to 300, not after 300. At what time t is the number of people in line a minimum? Right there, you know it's candidate test problem. And then it says to the nearest whole number, find the number of people in line at this time. So not only do they want the time, they want the number of people. It's a little bit different than the previous problem because they want time and people. Okay, so what do? We find out where is r of t minus 0.7 equal to 0. But to make it really easy on ourselves, where is r of t equal to 0.7? That will give us our candidates. Use your graphing calculator, put 0.7 into y2, find out where these two equations are equal to each other, and then we'll have our candidates. And remember, it's only from 0 to 300. Almost done. What do we got? Is 33 one of them? $33? 33 point what? 013. Okay, what's the next one? Okay, so those are our candidates. Now let's find the number of people in line. That would be integrate the rates to find the amount. Initial quantity is 20, right? Plus change in amount. So that would be 0. Are you guys okay if I just put t up here? And then we just enter in the different t values? And that would be r of t minus 0.7 dt. Now the first one's not too bad. At time 0, that's 20 plus 0 is just 20. How many people are in line at time 300, guys? You already figured it out. 80. Use your calculator real quick and just figure out how many people are in line at 33 seconds and 166 seconds.
Oh, that's me.
And what do we got? And here? Okay, so obviously, what is the minimum number of people? Rounded? 4, right? So let's state it. The minimum number of people in line is approximately 4 people at time t equal 33.013 seconds. Now up here we probably should have said seconds also, guys. I forgot to put the units on that one. Huh? Yeah, that's fine. All right, any questions on this? Okay, now for tomorrow.